In our culture, we believe that reality means physical things. The question is not whether the world is real or not. The question is, what is reality? In this series, we are delighted to have Professor Karl Friston. Is a theoretical neuroscientist and an authority on brain imaging, with Dr. Chris Field, a philosopher and an independent scientist in theoretical physics and cognitive neuroscience. The topic of our discussion today is the observer versus the observed.
Welcome, Professor Friston. Welcome, Dr. Field.
Thank you.
Thank you.
So anything interesting going for both of you? Have you been anywhere lately beside work, Professor Friston?
No, I'm afraid not. I've just, but my work is a holiday, so
Chris, have you been anywhere lately? Anything interesting going for you this year?
No, I've had my stepmother visiting for a week. So we've had a bit of a family week this last week.
Today, you know that today is the 5th day of Chinese New Year. Yeah. This year is a rabbit year. Our calendar just changed. Today is the 5th day of it. Tell us briefly how your career began.
My career?
Yeah.
Yeah. So I started as a medical trainee, largely because I wanted to do what was called in those days mathematical psychology. But my careers advisor mistakenly thought that I had to be a psychiatrist first. So I went to university dutifully to study psychiatry, but was able to do physics as an undergraduate. So I did natural sciences that included psychology and physics, and then became a medic and a psychiatrist. And then at the earliest opportunity, returned to the kind of research that I wanted to do as an adolescent, which was basically mathematical psychology.
So this book, Professor Friston, you say you're going to write about something about angel shit. I heard a talk about you talking about a book that you want to write. So if you're going to write a book about an angel shit, so would it be your philosophy or would it be something different? Could you talk on that, please?
Yes, yes. The idea, the word or the phrase or the concept angel shit was something that arose during my early psychiatric training from what was called, in fact, is called T group therapy. So part of my training was to live in a therapeutic community with about 30 people with chronic schizophrenia. So I spent about 2 years of my life living in this somewhat isolated community with psychiatric nurses and doctors and people with schizophrenia. And every week we would have several group sessions. And in these sessions, all sorts of wonderful things were talked about. And one of the more memorable themes was this notion from a very high-functioning and very endearing young man with schizophrenia who just came up with this notion of angel shit. And it just struck me as such an interesting conjunction of things that we don't normally associate, you know, a nice expression of what's called Knight's move or lateral thinking in the psychopathology of schizophrenia, but also reflecting the creativity of somebody who's able to think outside normal bounds and to transcend the normal syntax and semantics and the language that we usually share. So I've always remembered that instance and the phrase angel shit. And I thought to myself, when I get older, I will write a book called Angel Shit. But as I get older, I realize there is no time to write books. So I'm afraid I won't be writing a book called Angel Shit.
You won't be? Thank you. So, Chris, you began as an experimental physicist. Could you tell us more?
Well, I began in graduate school working at a small accelerator doing nuclear structure physics. And partway through that era, for various reasons, switched into philosophy and took up with people doing artificial intelligence. And shortly after that, ended up applying some of that work in work for the Human Genome Project. So I spent a good deal of my career in the Human Genome Project. So I have kind of a mixed bag of a past.
So you also find time to be a volunteer as a firefighter, right, Chris?
A small village in New Mexico, and the fire department was one of the things that held our small village with a very diverse population together. And so I spent a few years doing that. It was very interesting. Dealt with a lot of car wrecks on icy roads in the middle of the winter.
Thank you. So, two great minds. Let's get serious now. So, when we say reality in our culture, we will say reality means physical thing. So, shall we go to Karl first? What did you mean when we say reality?
I'm trying to, when you say what do we mean, I would imagine that from a philosophical point of view, we're talking about metaphysics. So yesterday I was given a brief tutorial on metaphysics. And from the point of view of the free energy principle, which is the lens through which I usually view many things, reality, I guess, would correspond to the states or the configuration of things beyond our sensorium, beyond our Markov blanket, beyond our holographic screen. So they would be the putative causes of the things that we can read from nature, or that we would think about in terms of the sensory impressions and our sensory epithelia, or, as I'm hoping Chris will talk about, the sensory bits, the readable bits on some screen or veil or boundary or holographic screen that separates me from the rest of the universe. So reality on that view is just the exterior. And strictly speaking, from my point of view, that reality is something which is constructed on the inside, and can only ever
on the
be
inside, as in our awareness, our experience.
Yeah,
constructed inside.
Yeah. So I imagine that you will want to talk about this issue from the perspective of the free energy principle, read in two ways. Read from the point of view of a classical physicist's point of view, and possibly also nowadays a cognitive neuroscientist point of view, in the sense of things like predictive processing. But there's another way of reading it, which is maybe a more generic way, which is the quantum information theoretic way of understanding things, that I'm hoping to learn more about when you start quizzing Chris. So the classical view means that you are separating all states of any given universe into separate subsets with a particular partition that separates or individuates the internal states, the interior of something, from the exterior, the external states. And there are that separation is defined in terms of a Markov blanket,
Markov blanket
outside. So if I am somewhere in my brain, or my brain is part of me, then the internal states would be my neuronal states, and the sensory part of my Markov blanket would be those signals that correspond to sensory receptors, say, vision and hearing, but also interoception. Anything that reports or signifies changes in the outside, in the external states, that is available to me. So when I talk about the inside, I mean the internal, the bulk on the inside of, say, a brain, the kind of thing that we study with brain imaging, for example, or indeed make inferences about as experimental psychologists using psychophysics or other psychological tools to make a guess about what's going on the inside of somebody's head.
Thank you. Chris?
Well, I certainly won't disagree with that. I'll translate your question a bit to what are we talking about when we talk about the physical? And here we can look back at the history of physics as a discipline, which evolved from something that talked about ordinary objects like planets and cannonballs and such, into something that now is formulated, at least in many sectors of the discipline, as an information theory that basically talks about information and information processing. So, in a sense, the boundaries between physics and computing are starting to dissolve in at least certain parts of physics, quantum cosmology, for example. So when we talk about the physical, we're talking about something that can be characterized in terms of some sort of state space, something that has distinguishable configurations or states. And so when we talk about the physical, in a sense, we're making some assumption about how we're going to characterize what can be distinguished. And hence we're talking about information, which is what it means to distinguish something is to talk about information. So I tend to think about your question and also Karl's answer in terms of a division of some universe, as Karl was saying, and some physicists refer to this as a multiverse, into two pieces that exchange information by physically interacting. And to ask, what does that exchange of information look like? How can we model that exchange of information? And how can we model what the systems on both sides of this division that we've stipulated, how can we model what they do with the information? So how does each agent or entity act on the other one? And a natural way to think about what they do with the information is clearly the theory of computation. They're processing the information in some way. So it's very natural to think of this physical interaction, as we would call it, as a communication between two entities who are each receiving information from the other, doing something with it, which we can think of as a decision process or a computational process. And then they're sending a message back, or they're acting on the other system in some physical way. All of these ways of talking are formally completely equivalent. So one can bring the language of communication and the language of computing to bear on any physical interaction. So this naturally raises the question, if we think of each system as some kind of information processor, how do they structure the input that they receive from the other system? And one way to think about that question is to ask, can they detect correlated patterns in the input that they get from the other system? So if we think of this in communication language, can they detect words or sentences or other meaningful subsets in the communications they get from the other system? If we think about it in terms of a sense like vision, we would ask, can they see objects that hold together over time? And being able to detect such structure in the information that they receive, that each receives from the other system, is necessary in order to do any sort of prediction. So when Karl talks about the FEP, it's a least action principle that has to do with minimizing uncertainty about what one's interaction partner will do next. And being able to do predictions requires being able to capture some kinds of regularities in the input coming from the other system. So one has to be able to locate parts of that signal that have relatively low entropy. In other words, some sort of relative stability over time. So if we pursue this line of thinking, we're very quickly led to viewing what we call ordinary objects, like planets or billiard balls or computers or each other, as constructs, as Karl put it, because they are areas of low entropy in the signals that we're receiving from whatever it is that we're interacting with, that we see only via the messages that it sends to us, or only via the actions that it takes on us. And so what is often called reality, what we see all around us and hear all around us, is in that sense a construct. It's something that we have to be smart enough to put together using whatever information processing facilities that we have, including, of course, those in our brains. And that leads us, of course, almost immediately to ask a different question, which is, lots of the things we see around us look for all the world like other agents rather like us, not just other humans, but all other organisms. And so we can ask, how do they see their world? And what is an object for them? How do they view what their environment is doing to them all the time? And so one is quickly drawn into a kind of ethology, if you will, concerned with how other organisms process what they're getting from their environments.
Thank you. Karl, do you have anything to add before we move on?
Lots of things come to mind. I think it might be quite useful just to paraphrase some of the terms that Chris was using in the language of inference and Bayesian inference in particular, just to put a bit of intuition for those people who are not as fluent in quantum information theory as other people are.
Yeah.
So, words like computation, information processing, I would also say measurement, can be written, as Chris nicely expressed. What natural way do we have of describing the sense that is made of this information that is arriving on our sensory epithelia or on our Markov blanket or in the quantum formulation on the holographic screen? One way of talking about information processing is just to cast it as belief updating, where you've introduced now the notion of a probability distribution. So if you just think about reality being a particular dynamics of probability distributions, very much like quantum physics, then what you are talking about when you talk about information processing is the change in some probabilistic representation on the inside in the brain, for example, that is induced or consequent upon a certain set of sensory inputs. And this belief updating can be read in many different ways, from the purely mathematical in terms of movement on a statistical manifold. So every point in these special spaces, these special manifolds, corresponds to a certain belief, where a belief is just a probability distribution over reality, which are the external states, So you never see them, but you can make inferences about them. So for me, information processing is just a movement on a statistical manifold. And then Chris also mentioned the word structure. How do we make sense of, how do we detect those regimes of low entropy, those bits of information that have some causal structure? So in things like radical constructivism and indeed Bayesian modeling, this would be structure learning. It's getting the frames of reference right so that you are using the right kind of manifold to do your information processing by moving around on that manifold so that you can make sense of the data, looking for symmetries and invariances that would correspond to, again, as Chris noted, objects have certain invariances, that they have certain features that are invariant to their location. And the location may be, and location as a construct doesn't necessarily depend upon the object that is at that location. So teasing apart, finding the conditional independences is one way of looking at getting these frames of reference fit for purpose to do the best kind of information processing. And the best kind is the one that makes sense of all these sensory signals. Sometimes some people refer to that as sort of being Bayes optimal, being optimal in the sense of finding that structure, that frame of reference on the inside upon which this belief updating and information processing plays out, that renders all of those input as likely as possible. And that's, from my point of view, it's as simple as that. So you can score this as likely as possible in terms of things like Bayesian model evidence, or the complement or the inverse of that, things like variational free energy or prediction error, surprisal in information theory, or more in terms of folk psychology, surprise. So the best stuff is the stuff or the best sense making is a sense making that renders you the least surprised about seeing this pattern of sensory impressions from reality out there. You'll never know what reality out there is doing, but at least you can make the best guess of this by finding the right kinds of structures. What Chris has done, though, he's taken us right into the much more glorious realm of two sense-making systems that are talking to each other. And further to that, there's some isomorphism there. So you imagine there's two highly sophisticated and evolved structures that are passing messages across with a shared screen, if you like, or a shared Markov blanket, a shared separation. And all the interesting issues that arise from that can be cast in terms of say generalized synchrony from the point of view of classical dynamical systems theory, from the point of view of entanglement in quantum treatments. But the other interesting perspective that Chris has as his denouement of the argument is that to get this minimum surprising, maximally predictable state of affairs, then there has to be a shared narrative on both sides, a shared structure to establish this synchrony, which could be read in terms of sense-making and information processing as basically resolving the hermeneutics problem. And of course, how do we do that? Well, it's with language. So, and if you generalize that notion of language, then all communication is just good belief updating in the service of explaining something out there that actually shares some reference frame, or shares some narrative or world model or the statistical manifold with me. And I have to learn, I have to learn about you. We have to speak the same language, and we converge upon the same kind of structure, just to make sure that the sensations that we receive are as likely and as predictable as possible.
Thank you. So last week we have Don and Levin on our show. So Don reduced reality to a network of conscious agents. He then went one step further. That was, he reduced all this multiplicity and diversity of conscious agents into a single consciousness, because they're all conscious experiences. So the consciousness is the common factors of it. So my question is, at what level one can be described as having a conscious experience of? Can we go to Chris?
I take a fairly radical or deflationary, or one could call it various things, view of this. And reason in this way, that what we call experience is always determinate or classical. It's what in a sense we mean by classical information. We don't see Schrodinger's cat as being dead and alive. We see Schrodinger's cat as being either one or the other. And we don't see people as being located both here and there. We see them located in one place and saying one thing, and so on. So that's classical information. And from a fairly strict kind of quantum information theoretic perspective, the only place that one expects to see classical information is on a boundary between two interacting systems. So if we think of classical information as only encoded on boundaries, and if we think of experience as classical information, then it's fairly natural to think that experience is what's happening on a boundary. And because that's where the classical information is, it's not anywhere else in this very kind of strict quantum theoretic point of view. So in that case, one can think of the universe, if you will, as this big system, which we can describe using at least a quantum formalism. And one can think of slicing it in various ways. And so slice it in some arbitrary way. You've created a boundary. Now that boundary may not be stable. If the interaction across that boundary is very strong, then the boundary is not going to pick out two systems that one can talk about as if they're different. And formally, if the interaction is strong enough that the entanglement entropy across that boundary is large, then those systems don't really have separate identities. They're too correlated to be considered to be just exchanging classical information. But if the interaction across the boundary that you've picked is fairly weak, then the two systems are more or less independent of each other, and you can think of them as separate entities that have their own states and that are exchanging some relatively small amount of information with each other compared to the amount of information that they've got inside. And that's the place where the free energy principle is helpful, because it depends on this conditional independence of one system from another. So now, if you've picked a slice like that, when you slice the universe up, then that boundary is going to encode some classical information. And I see no reason not to think of all of that classical information as experiential, or think of it in experiential terms. And we're very familiar with that in our own case, and we're reasonably familiar with it in the case of animals like us. And we have essentially no familiarity at all with it in the case of other systems. But I don't see any reason not to think of it that way for arbitrary systems that interact sufficiently weakly with their environments. So I would be either bold or crazy and just say we should think of experience in general as the classical information that's encoded on boundaries, where the boundaries can be arbitrary, but the amount of classical information they encode depends on whether they separate systems that are separable or mutually conditionally independent in the way that Karl has mentioned.
I agree with that absolutely entirely. One nice thing about the quantum formulation of the FEP is its scale-free nature. And one could read what Chris just said as saying that there are Markov blankets at many, many different scales, and certain kinds of systems that are enshrouded in a particular blanket or boundary will certainly could certainly be described as doing belief updating and making sense of data, experiencing the sensory inputs in the formulation that Chris just offered. And as such, I think it's perfectly permissible to say that there can be a universe of collective consciousnesses, just in virtue of the fact that, as we've just heard, there are many, many ways of carving up conditional independences and developing Markov blankets at different scales. So I see no mathematical problem with having distributed cognition and a mathematical form of collective consciousness in which there is a minimization of the joint free energy of multiple Markov blankets that are all enshrouded by a Markov blanket defining that particular community of sense-making agents, for example. Those agents could be people, but I would also submit, if you just think about the brain as a very carefully structured ensemble of Markov blanketed, bounded systems, neural populations, specialized cortical areas that themselves comprise lots of delicately structured Markov blankets at the level of single neurons, and then within a single neuron, axonal dendritic processes, right down to the molecular level. So viewed from the scale-free perspective, from Gaia down to the molecular scale, then if the same kinds of principles apply, and those principles can be read in terms of sense making and sentience of a basal or sort of elementary form, then it can be no other way that consciousness cannot be tied to one privileged Markov blanket. So I think that's an interesting observation. And it does strike me, though, that you may be asking, there may be a difference between experience and qualitative experience. So you may be asking about qualia, and does every does every individuated boundary system, are you licensed to suppose that it has the capacity to experience qualitatively in a phenomenological sense? I think that's, so we're touching on things like panpsychism now, and I think there are two ways that you can read this. The first is, yes, obviously, there is a basal sense making, a basal distributed cognition, a distributed consciousness, that is evident in any kind of communicating sparsely coupled system, from multiple molecules to multiple cells to organs in my body to institutions, bodies of people. Or you could argue, well, yes, that's fine, but are there any special kinds of sense making that would give you the qualitative experience that people talk about in philosophy? I would suggest that there may be, and after many years of conversing with people in the field, I think one key distinction between the kind of experience that is generic to any self-evidencing system that can be individuated from its milieu, its external milieu, its econiche or environment, is the capacity to select, to act on the world out there in such a way that it has consequences for other sensory impressions. So if I was limiting myself to the brain, for example, and I was thinking like a psychologist, this would be attention, mental action, actively selecting what kinds of sensory impressions make a difference to my information processing and my belief updating. If I was a motor physiologist, I'd be talking about being able to move, say, my eyes and look at that. So seeing becomes looking at. If I was a physiologist, I would make a distinction between the things that I have qualitative experience of and things that I don't. So when I breathe, I can attend to and also, using my muscles, exert volitional control over my respiration. But I can't do that with my heart. So I'm not aware, I don't have a phenomenology of my cardiac cycle, but I do of my respiratory cycle. So I think that the special kinds of actions, the other way, if you like, the other direction of travel through the boundaries, or the other direction of travel in terms of information channels that transcend or transgress these boundaries, or the Markov blanket, which is writing to the boundary, or then acting upon the other side, which could be another person. I think that may be an important kind of structure that would be possibly necessary to actually have a qualitative experience as opposed to just an experience.
Thank you. So, Chris, it's an entanglement then between the two, right? Through the user interface, like Don's saying. So it's an entangled system between the two interactions then, right? Is that what you're saying?
Well, entanglement is one of those words that has different meanings in different disciplines. In physics, entanglement or quantum entanglement is defined as the state of non-separability. So if a system is entangled, then one can't talk about the states of its components independently. So entanglement is, in that sense, is a limiting case in which the interaction across the boundary is both strong enough and correlated enough that one can no longer distinguish between the two interacting systems. So that's a very different meaning than some more classical uses of the term entanglement, which just mean a very close correlation. So entanglement, as the word is used in physics, means a correlation that effectively destroys separate identities. So if a system is entangled, one, in a sense, can't draw a meaningful boundary across it. But I would like to say something in response to what Karl just said, and your question about, in a sense, real consciousness.
Experience.
Right, real phenomenal consciousness. It clearly depends on, organisms or systems in general can clearly vary enormously in what they can detect about the world and how they can act on the world. For example, you could ask for a system, can it detect spatial dimensionality in the world? Does it live in a world that appears to it to have any spatial coordinates? And clearly for our kind of consciousness, we have to be able to overlay some spatial coordinate system on our experience, or it doesn't make any sense at all. We can't talk about object identity. We can't talk about motion. We can't talk about any of that stuff without spatial coordinates. And we can ask, can a system detect the passage of time, which requires having a certain kind of memory so that I can tell now from what happened, a few seconds ago. That depends on my being able to remember a few seconds ago. So these are capabilities that systems have to have experiences like ours. But I think of a dividing line that I might like to propose is between systems that are capable of acting in order to get more information in the future, which Karl has characterized in his work as acting in pursuit of epistemic value. And in ordinary language, one would characterize as curiosity, acting with curiosity. And I think that what is characteristic of the systems that we tend to regard as having phenomenal consciousness of the sort that we have is that they act with curiosity fairly clearly. Other mammals, for example, are all curious. So I would just throw that into the conversation as a thing that I think characterizes the sorts of systems that we regard as interesting from the point of view of what their experience is like.
Yeah, and just to bring the last 2 points together, in acting in a way to resolve your expected surprise, which is just uncertainty, that would be the definition of curiosity, you have to have a frame of reference, a structure on the inside that can predict the consequences of any particular action. So by definition, this introduces a form of temporality, whether the agent knows that this is time, but there's certainly an ordinal aspect that something will happen contingent upon doing this. And I think that this lends a what some people refer to as a temporal thickness or temporal depth to the way that we make sense of data. And I think that comes for free when you talk about systems that have this kind of curiosity, curious creatures, that I think you would have to entertain in order to as requisite for having any kind of phenomenal consciousness. The reason I say that, of course, is that modeling the consequences of action over some time-like sequence just is memory. So, I think the two come for free from the same commitment to certain systems that have this capacity to not only resolve or minimize their surprise in the moment, but also act upon a world in a way that they anticipate they will minimize their expected surprise and resolve uncertainty. And it is something that has underwritten all of our behavior, and certainly behavior in statistics since the 1950s. So this is called the principle of optimal Bayesian experimental design. Namely, what is the best experiment? What's the best action? What's the best sort of writing to the world, acting upon the world? That will minimize my uncertainty, and that's the same as maximize my expected information gain that you can compute. So if you know the state of the world and you know what you don't know, then you can estimate how much uncertainty you can resolve if I did that as opposed to this. And of course, that's just what we do as scientists. We design our experiments exactly in the way that resolves the greatest amount of uncertainty about our competing hypotheses, as scored by maximizing expected information gain. It's something that re-emerged in the 1990s in the guise in machine learning as active learning. What data point do I commit to trying to search for that's going to best resolve the uncertainty about the unknowns in my particular world model or statistical model of these data. So I think what Chris has just said is absolutely central. And notice that there are probably very few of these kinds of systems in our universe. A thermostat doesn't have memory. A thermostat, put very simply, cannot plan. What we're talking about here are systems that at least look as if they are planning. So there's a whole universe of very functional, very adaptive systems, creatures, particles, phenotypes out there that don't plan the weather, evolution, thermostats. But there are maybe a small number of things that do have these temporary thick world models under the hood, the structures that we were talking about before, that enable them to evince this kind of curiosity. And it was exactly that kind of action I was sort of hinting at before, but I didn't think we were going to get quite so far into the weeds in terms of that's exactly the
it's
way
my brain, how it functions. Yeah, I'm sorry, the jumpy of it, because it's how my brain, when something's stuck, I need to get it out. So we quickly move on. When Chris say observers is everywhere, observation is an information transfer. Chris say that. So if you have to define what an observer is, could you define it precisely, what an observer through a physics science? And Kyle, could you define on the neuroscience side? Because to me, observer is the observer has information. Am I correct? It could be looking at like the ego or the identity. But Chris say observers is everywhere. So can we just unpack the observer, that what both of you meant? Could Chris go first?
Sure. When I talk about an observer, I admittedly use the term very loosely in a way that I think lots of physicists do when they say things like the observer is just another quantum system. I think of an observer as minimally any system that interacts with an environment such that the joint observer environment system state is separable, so they're not entangled. And under those conditions, one can talk about the state of the observer and how the state of the observer changes as it receives information from the environment and as it acts on the environment. So an observer is something that can receive information and act in a conditionally independent way from its environment. Now, that's an extremely minimal definition, and lots of things qualify. So one can now start layering abilities on top of this system to make it more and more capable. So when we use the word observer in English, we're referring to systems that at least can pick out different objects in the environment and act on them reasonably specifically. And I say reasonably specifically because there are no actions without side effects. But can act reasonably specifically on objects that it can distinguish from the rest of what's going on in its environment. So this gets back to our previous conversation about temporal depth and object identity and all of these other things. So there are these two senses of observer, one of which is extremely minimal and only really depends on the existence of a Markov blanket, which is what separability gives you. And the other of which can be arbitrarily sophisticated with a large memory, for example, a large ability to model statistically the data that it receives, and an ability to act with a fair degree of precision on the environment that it sees. And I would say everything in between is an observer with some set of capabilities or other. They may be fairly small, and they may be quite sophisticated.
Kyle?
Yeah, again, I agree entirely. I mean, in my world, observation, which is the thing that defines something as an observer, measurement, inference, and existence are all the same thing. So again, from a deflationary, taking the deflationary perspective that Chris has articulated, anything that can be separated or identified, individuated from its embedding environment must, by definition, have a Markov blanket. That Markov blanket must comprise some sensory state, so it must be its existence belies the fact that, or is evidence that it is observing in this very minimalist sense that it is processing sensory information. And I would contend that this can be read, I repeat, as measurement. It can be repeated, in the sort of quantum or physicist's sense, and that very minimal definition of what it is to be an observer. It is to be an observer is just to exist. From the point of view of a neuroscientist, I think you're talking about this more elaborate kind of observation that has this curiosity attached to it. So the kinds of particles that I spend my time measuring are people and brains. So these particles, these very complicated, very expressive particles, have a particular kind of observation that basically we were talking about before, which is the kind of observation that they can plan to make the good observations, the uncertainty resolving observations, the just is an expression of this responding to epistemic affordances, responding to salient cues in the inferred cues in the environment, to show this curiosity that characterizes. So if you limit sort of observation to this informed, planned observation, then I think that would be the kind of observer that I would study as a neuroscientist. Is that a sufficient definition? I do repeat though, the notion of an observer is it's almost unnecessary in the sense that as soon as you can separate anything from everything else, the coupling between everything else and the thing in question constitutes in effect a kind of observation. Then the interesting questions are what happens on the inside of the thing in question. And that's basically the story that the FEP tells in terms of trying to describe this information processing, this belief updating in relation to things like Bayesian inference and sense making and minimizing prediction error, and ultimately planning to minimize prediction error by taking the right kinds of actions, designing the right experiments, which is exactly what we're doing now. So you asking me questions and me trying to work out what's going to resolve your uncertainty. This is exactly this kind of curious behavior that I think characterizes the kind of observers I think that you're talking about when it comes to getting a response from a neuroscientist.
Yeah. Chris, have you had anything to add on?
No, I think that sums it up quite nicely. I really like the motto, to be an observer is just to exist. Yes, I completely agree.
So Krishnamurti and Bohm say the observer is the observed. So what's your thought on that then?
The observer
let's say the observer is the observed. It's
okay.
like when we talk about the inside of it, right? You have an observer position, you have an ego. So you can observe yourself. That's what they're talking about, right? So I just wonder what's your thoughts on that?
Right.
Because your observer is just existing, whereas if we can go deeper, the observer is just observing with no content. That's what I actually thought it is. So I'm still a bit confused on that part. Yeah.
Yeah, so I think that's a great question that could be taken in two directions. One direction, which I think we won't go down, is that there is a simple truth that whenever there is an observer, there is also an observed, in the simple sense that we were talking about before. If you have any universe and you carve it into two, you put a partition or a boundary between one part of the universe and the other part of the universe, then one becomes an observer, but there's also something on the other side that is observing the observer. And that phrase, observing the observer, is a good description of me as a neuroscientist, spending most of my life trying to work out what's going on inside other people's heads. And it's actually a very difficult problem. But I think you're talking now more about me observing my information processing in the spirit of things like higher order thought theories of consciousness or metacognition, perhaps even touching upon the notions of self-modeling, speaking here of the work of people like Thomas Metzinger. And I think that's an essential part of the kind of observers that we're talking about when we're talking about people, and possibly most animals. I think probably most animals. And in a sense, that sort of observing the observer becoming the observed, is a necessary consequence of something that you actually said in your question, which is the notion of depth. So depth can certainly be applied in the temporal domain, but also has it is an important attribute of the structures that we use to do our information processing and our belief updating. The structures, I'm referring to structure here in the spirit of structure learning a world model or an internal model of what caused my sensations. Now, if you have a deep structure, then by definition, you have a hierarchical depth. And if you have a hierarchical depth, each hierarchy is observing what's going on at the level below. And so the very existence of systems that whose bulk or internal states are doing the kind of information processing that enable them to plan have a hierarchical structure. They have both a temporal and hierarchical depth, and therefore they must, if you like, have this attribute that you can read them as observing themselves simply because they possess this hierarchical structure. Just to finish, that notion of deep is exactly what underlies deep learning in machine learning. So when you look at the fantastic achievements of sense making and sort of recapitulating, say, in generative artificial intelligence, generative AI, it invariably involves a deep neural network or a deep world model. And that deepness just depends upon having hidden layer upon hidden layer upon hidden layer that defines this hierarchical structure, this sort of frames of reference of frames of reference of frames of reference, usually increasing in time as you get deeper and deeper into the hierarchy, or in some instances, a heterarchy. So I think there is literally a deep truth to the notion that the kind of sense making and the kind of the way that you and I experience our world is deep in the sense that it can be read as a hierarchical sense making, where each level is both observed and observer. It is observing the level below, and it is observed by the level above.
Thank you, Chris.
Well, I think that's excuse me, a very nice way of putting it. I would refer to some terminology that our colleague Mike Levin has proposed of what he calls a multi-scale competency architecture, which all organisms have. Each level of the hierarchy is competent to do certain things essentially on its own without being told. And it's that sense of hierarchy where at each level there are certain defined capabilities that is at play here. in these kinds of hierarchical models. But I'd also go back to another way of addressing your question in terms of self-observation, and ask, what's the minimal kind of self-observation that's called for in this kind of theory? And in a sense, it's some kind of observation of what is my stress level. What is my current level of uncertainty? And one can see this as far down in phylogeny as one chooses to look. So, for example, molecular biologists very early studied, one of the earliest studied systems in microbes like E. coli is the stress response system. And it was first identified by studying responses to heat stress. So the whole family of response genes got called heat shock genes, but they're really stress detectors. And any cell, even down to prokaryotic or microbial cells, has a huge repertoire of stress detectors and defensive strategies of one kind or other that don't make any sense physiologically unless we understand them as measuring their own state, as being able to detect that they're being attacked by viruses, or their temperature is high enough that their proteins are starting to fall apart and quit working, or they're too cold, the opposite extreme, and diffusion is no longer working, and so reactions are slowing down. So this sense of self-observation, if you will, is very, very deep biologically, and seems to be a defining feature of the things that we refer to as alive.
It's just the awareness of it, right, Chris?
Well, yeah, I don't think that the term observe makes any sense without thinking of being aware of what one is observing.
Yeah.
So yeah, I think that the poor bacteria actually don't like it when you heat them up too much.
Yes, so I'm smiling
You
at
agree?
this notion of being
Me
cruel to
too.
bacteria. Just thinking about that question from the point of view, or that point about stress detectors, from the point of view of psychiatry and the sort of the human experience. I think there's another important truism here that we've referred to, or Chris has referred to repeatedly, the importance of being precise, the importance of rendering everything predictable and unambiguous as possible. I mean, one way of reading this imperative that underlies curiosity is to resolve uncertainty and keeping things very, very precise. If that's the game, and I would suggest it is the game in a very mathematical sense, that if I'm in the game of minimizing the surprise I expect following this action, then I am simply trying to minimize the expected surprise, or which is the entropy or the uncertainty. I'm always trying to resolve uncertainty about my lived world. If I was able to measure the uncertainty of my current state of being, then you can see that increases in uncertainty are going to have a very negative valence, and decreases of uncertainty, the kinds of things that I'm going to aspire to. And in one sense, of course, novelty seeking, information seeking is exactly to reduce that uncertainty. But the converse, I think, holds the key to many mechanical understandings of psychopathology and anxiety. So usually in psychiatry, when you look at the the sorts of aberrant belief updating and sense making that underlie all sorts of conditions, ranging from obsessional compulsive disorder through to autism, schizophrenia, through to depression, then you can always find, and not least, of course, anxiety disorders, particularly generalized anxiety disorders, and sort of chronic stress. There's one common theme throughout, and that's a failure to resolve uncertainty, a failure to eliminate in the right way the uncertainty that you sense yourself as currently experiencing. There are all sorts of ways of resolving uncertainty. You could just hide from the world, so you could have agoraphobia, or you could become socially and emotionally withdrawn, and even physically, manifest psychomotor poverty symptoms of, severe depression. If you had severe autism, one way of minimizing your uncertainty and surprise is just to avoid any potential situation in which there's, say, interpersonal interactions in which there's going to be unpredictable or surprising responses, or indeed create your own predictable sensations, just stimming behavior, self-stimulation behavior. And I think all of these sort of pathological, although strictly speaking there is no pathological behavior, it's all based optimal at some point, but these aberrant kinds of behaviors, if the person was like me, can always be read as an attempt to minimize the kind of stress. But this is stress which can be read literally in terms of the entropy or the uncertainty associated with particular belief states during your sense making. So I think that perspective has a lot of practical utility when it comes to formalizing theories of bad sense making in psychopathology, and indeed has found a certain traction in fields like computational psychiatry.
Thank you. We're going to go straight to Andy. Your question, Andy, who your question to?
Okay, wow. Thank you so much, guys. This is amazing. My pre-prepared question, I think, has just dissolved. So I'm think of this more just a perturbation of the conversation. In you guys' minds, and this is for either of you, is an understanding of our consciousness dependent on some notion of consciousness being a fundamental thing, separate from our sort of physicalist understanding of the universe, complex energetic information processes arising from the standard model and plus whatever sensible near future extensions to that model might happen, like necessarily fail in describing our consciousness. That's as good as I got, I think. Thank you so much.
Karl, do you want to take that first?
Yeah, I think that question speaks to what was quite a large part of the focus of our conversation, which I think is the distinction between the consciousness that has a phenomenal aspect and usually has a self-referential and perspectival aspect to it that can be articulated, not least to ourselves, that includes some kind of self-modeling. So I would just fall back on the way that we would describe the kinds of systems that can support that kind of information processing and modeling. And I repeat, sort of modeling oneself as part of the active process of gathering the data that you are trying to model. So again, we come back to this notion of soliciting the right kind of information, the right kind of cues and feedback from the world, from nature, from our partners and our friends and colleagues, which is this sort of curiosity, planning to resolve uncertainty. And I repeat, that is the special preserve of a very small number of systems, possibly just the handful of people we find on, or animals that we find on this earth. And in that sense, a description of measurement and the physics of measurement, a metrological approach to physics would not be sufficient, I think, to fully understand that kind of rich, thick, deep, curious consciousness that has these phenomenological attributes. And I'll just also just put out there for Chris's comment, You could argue that the standard model and that physics and all the mathematical and narrative languages upon which that is predicated is just a shared construct. It's just part of our world model, our sense making, that actually inherits from a kind of collective unconscious that would be ascribed to evolutionary psychology or cultural niche construction. But at the end of the day, it's just another hypothesis. Maths is just another hypothesis that we use to make sense. It feels really solid because it's shared so universally and has that unreasonable precision and efficacy, just to come back to a really key point that Chris has made repeatedly. If it's precise in its explanatory power, then it's going to find a home in our existential architectures, the structures of the way that we make sense or anything that survives, but in particular the way that we make sense of our world. Chris, over to you for that one.
Yeah. Thank you. I would just add that the standard model is a lovely construct. It's a theory of interactions and the symmetries of interactions. It's not a theory of what exists. And essentially what we've been talking about today is a way of shifting our thinking about what systems are, what it means to be a system that's interacting with an environment. And when one talks about information exchange or information or experience, one's using a language that is not captured, strictly speaking, by a standard model-like description of the symmetries of interaction, because one's added to that description of interaction some description of the things that are interacting. And that's, in a sense, has been provided by physics with the notion of a particle or the notion of a field. But even underlying those notions is this very informal notion of a system. And it's that notion of a system that I think has to be added in order to fully capture what we've been trying to talk about today. I would say that what we've been discussing today is mainly a different point of view on the physics of interaction than has typically been pursued in physics up until, I would say, the past couple of decades, where a lot of attention has gone to describing physical interactions in terms of communication protocols and information exchange, using some of the language that we've been using today. So I don't think that one has to assume, if you will, new metaphysics. I think one just has to take a slightly different point of view on things.
Sorry for breaking in, Andy. Can we move on quickly to Kyle, please?
Wonderful. And I invited people to the stage just to tweak the algorithm and bring more ears to the outstanding, amazing speakers here. And thank you both very much for being here. A couple of things that I was listening to that I took particular interest in. First was like the anticipation and the modeling. I guess I've been in sports activities and careers in which I've had to have a great deal of anticipation. So much so that I'm almost thinking about the other aspect of it, because when there is no surprise, people become kind of conform to the conceptual understanding of the system itself, and they lose spontaneity. So I was just thinking about the benefit of eustress, because stress was mentioned before, but there is distress and eustress, and spontaneity for surprise. Another quick, and so I was just wondering if you could just briefly touch upon spontaneity, Karl. And then for the both of you, I was just wondering, I've been hearing some stuff about like collecting data for a representation of self. And I think this is what marketers do and companies that are taking all of our data. They're kind of like creating a digital twin to anticipate how we will actively infer throughout our lives and taking advantage of that. I was wondering if you have anything to say about that.
Thank you. I'll take the spontaneity question, which is a really interesting question. And one could read that in one of two ways. So in terms of, say, sports physiology or sort of the agenda of becoming a good sports person, spontaneity may be read in terms of automatization and habitization, becoming fluent, getting into the flow in the particular situation in which you have become skilled. And I think that would just be an expression of this imperative to do actively very precise belief updating with resolution of all reducible uncertainty. So you know exactly what you're going to do, and effectively you are responding reflexively and automatically in the situation through a series of movements or responses over which you have exquisite control, and also that you can predict expertly. So this would be, if you like, the end point of an uncertainty reducing scheme. But there's another kind of, if you like, spontaneity that is afforded when we now turn to the construction of deeper and deeper models. So, when one tries to model this kind of process, one then thinks, okay, well, what if we now put a deeper model, a deeper layer on top of the lower layer that's doing the spontaneous automated behavior? And usually that layer has a more temporally extended aspect to it. And it can now contextualize and make sense of different the evolving of say a game at a much longer time scale. What can happen with some once one's established these deep generative models or world models of me performing in a particular context is actually a pathology where you start to go back and start to attend to your more fluent automatized behaviors, and that can completely destroy the behavior. So I have colleagues who spend a lot of their time in clinics, neurologists, dealing with functional medical symptoms that arise when a sports professional can no longer play tennis or putt, simply because they're attending to the things that had previously been overlearned, and had become reflexive. So this is one of those nice instances of getting the estimates of uncertainty and precision wrong in your belief updating when you're actively engaged with the world. The final kind of spontaneity, I guess you're hinting at, is really that underwrites creativity and the way that we can spontaneously explore hypothesis spaces that provide alternative explanations for our sensed world, or indeed the world that we can create in terms of being artists or poets or inventive in our personal relationships. So that I think that's a very different kind of spontaneity, and I think it speaks to this aspect of curiosity, this imperative to resolve uncertainty. But if you want to resolve uncertainty, you have to have the capacity to develop a space of alternative hypotheses over which you can then resolve uncertainty. So I would look at this as one fundamental aspect of novelty seeking, having spontaneous ideas, aha moments that just encompass different explanations for the way the world works. And then once you have this hypothesis space, then you're able to either create or secure evidence. Oh, it works like that. This is a nice, simple, uncertainty resolving explanation.
Well, I'll just make a remark that when you talk about eustress, in a sense, you're talking about play, which is again something we observe in all of the organisms that we think of as having interesting sorts of consciousness. So yeah, I agree that it goes back to curiosity. But yeah,
thank you, Karl.
Those are organisms that can have fun.
Woohoo! Thank you, Karl, for that great questions. Can we move to Prakash quickly?
Yes, thank you, Ivy, and thank you very much, both the speakers. Very deep dive into what we think of as interaction between observer and the observed, or what we call as consciousness and the material around it. I want to overstep the boundary a little bit and go deeper and ask, if you're having a kind of spiritual experience, or if you are under the influence of psychedelics, what is the state of the observer there? Is there a witnessing that happens without an observer? And I just want to explore a little bit on that side, because it is an altered state of consciousness. So I just want to see what opinions you have on that. Thank you.
Sure, I'll say a little bit about that. I think one characteristic of these sorts of experiences is an absence of the usual kind of memory encoding, which has two consequences. I mean, one consequence is that one doesn't remember exactly what happened. And that's true of much of ordinary life as well. But another consequence is it allows experience without a whole lot of processing. And we're typically doing a tremendous amount of processing, thinking about the information that we're getting, thinking not necessarily consciously, but we're doing a lot with the information that we're getting, and using it to plan ahead, to adjust the overall structure of our network of expectations about the world. And if you turn that off, I think you get to see more in a sense of what's going on, because one isn't having to expend the energy to do all of the processing that we're constantly doing. So we don't, this also applies, I think, in at least some sense to the dream stage, which is also an altered state of consciousness. One doesn't have to spend a lot of effort, for example, trying to figure out whether the object you're seeing now is the same object that you were seeing a little while ago. So it's okay if that object is changing its properties in some interesting way. So I think these experiences are very interesting. It is kind of clear why, in a sense, they're liberating, or can achieve a certain level of house cleaning in the mind by stripping away expectations and not doing the kinds of cognitive work that we're often doing to cut experience up into little manageable fragments. Because all of that depends on being able to keep a lot in memory and to devote a whole lot of energy to computation. So backing off from that seems like clearly something that can be valuable.
Say that again, Chris.
I said you're probably more familiar with these sorts of experiences in terms of their neurological and also phenomenological properties.
Absolutely. To be clear, Chris does not mean that I take lots of drugs. It's because I'm a psychiatrist. So again, that's a great question. Ivy, you're going to be very cross with me because I've got so much to say about that question, but I'll say it very, very quickly. So there is
Professor
a very
Friston.
well worked out literature addressing exactly this question. And some of the words that Chris used in answer figure very prominently in this literature. And the literature has two sides. And I'll just start with the notion of house cleaning and housekeeping, and the important insights one gets from sleep research into our constructed realities and how sensitively they depend upon the precision of our belief updating. So in the brain, the precision of belief updating is literally described in predictive coding formulations of this kind of information processing in terms of precision-weighted prediction errors. And the precision is usually set physiologically by neuromodulatory transmitter systems, things like serotonin, 5-HT, noradrenaline, dopamine, oxytocin, and the like. And the key insight here is that dreaming as an altered state of consciousness is principally determined by the status and discharges of these ascending neuromodulated transmitter systems. So there's a very concrete, very well understood empirically set of mechanisms that tie together the precision of your belief updating and the differences in the way that we make sense of our world, even when asleep. You know, when we are dreaming, we are still making sense of a world. It's actually our self-constructed world that is sequestered from the actual sensory input by turning down the precision of the sensory prediction errors, but not reducing the precision of all the hierarchically deployed prediction errors in our brain. So dreaming and just the existence of dreams, I think, is as my erstwhile colleague who died a few years ago, Alan Hobson, one of the world's experts on sleep and dreaming, would say, if you want evidence for the brain as a constructive organ, making sense of its sensory impressions on its holographic screen or its Markov blanket, you need to look no further than the fact that we can dream. That is the only reality we really need to worry about. But it does depend, you know, the kind of sense making does depend very, very sensitively on neuromodulation and that controls the precision. Just one little link here, because Chris also used the word temperature. In my world, precision is inverse temperature. So you talk about softmax parameters and inverse temperature parameters, that is precision. So we're talking about cool-headed sense-making. Now, how does that relate to the other literature? Well, the other literature is on wakeful sense-making, where you interfere with exactly the same neurotransmitter systems. So all psychedelics effectively act as agonists on 5-HT2A receptors, which are really important receptor that set the precision or the gain or the precision weighting of the prediction errors. And that, to a certain extent, can be thought of as the inverse of sleeping. So here, you're emphasizing the precision of lower level sensory prediction errors with respect to your higher, deeper kinds of constructs. So I think the question was absolutely right, that you know, by pharmacologically altering the precision of our belief updating and the temperature differentially at different hierarchical levels of deep sense making can have profound effects on the way that we exert control or put prior constraints or prior beliefs in our experience into the mix when making sense of our sensations. Yeah, I was just going to conclude by pointing to the literature on psychedelics. One of the key authors in this field is a gentleman called Robin Carhart Harris. And the bottom line of the story that he tells is that psychedelics reduce the precision of very deep prior beliefs and enhance the precision of more sensory level processing. And that basically means that you are dissolving or relaxing the precision of higher level beliefs. So you are becoming more attentive to the sensorium.
We're going to quickly go to Ari.
Yeah, so the thing that so it's kind of a follow-up question to what Prakash asked, and it is like if there is a sense of observer not being there, then how can that be experience be valid or the consciousness be valid on that? And And the reason why I say that it is a follow-up question, because the moment we don't, as what Kyle said just now, we don't have that distinction of observer versus observed, and we don't go into that distinction as much, and then just factor in of conceivability with the concept of Markov blanket, as how much that conceivability can exist, and beyond that, if there is what Kyle is referring as dark void. So if it is audible, you guys can, as Prakash is giving thumbs up. Yeah, you guys can, answer on that.
I'll try to say something here. I see this question as asking about the limit of weak interaction between two systems. So if you think about a boundary between two systems that's supporting some interaction, one can always think of that as a communication channel from a formal perspective. And so one can ask about the limit as the bandwidth of that channel goes to zero. And as the bandwidth of the channel goes to zero, there's no information exchange. So there is, in a sense, no experiential content anymore. And I suspect that these experiences that you're describing are experiences of approaching that limit of no information exchange across the boundary. I mean, one can, there's a kind of brute force way to approach this limit is something like using sensory deprivation. But of course, that doesn't approach it very closely because it doesn't remove interoception. So I think it's a very difficult limit to actually approach and remain alive. But I think one can get closer than sensory deprivation. Yeah.
Chris, you could also argue that certain sleep states approach that in terms of neurochemical sensory deprivation, basically switching off apart from afferents from the oculomotor system, which are part of the central nervous system. Everything else is basically switched off. So one may be asking now, well, okay, if there's no information traffic across my Markov blanket, how do I make sense? And I think the answer to that comes again from this notion of a deeply structured internal model that, of course, is defined by a whole series of Markov blankets inside the head. So it comes back to observing the observer, that there's still good information processing you can do, even in the absence of sensations from the sensory receptors that people have. And there's an interesting mathematical take on this, which comes back to Chris's notion of housekeeping. If you remember right at the beginning, we were talking about the imperatives for good natural descriptions of things that exist inside and with Markov blankets, which is to maximize the evidence for effectively their internal models. Evidence can always be written down as accuracy minus complexity, which means there is still evidence maximizing information processing that can occur in the absence of sensory inputs, which can minimize the complexity. And what that translates to in sleep is basically exactly the housekeeping, removing redundant parts of the structure as we rehearse and find out what associations that we built up during the day are no longer necessary to provide a simple, minimally complex, but accurate account of what we have seen to date. But this only works because there are Markov blankets within Markov blankets, screens within screens within screens. It will only work with deep generative models. A thermostat will not be able to dream, but you and I can dream. But just connect it to the previous question as well. I don't know anything about the Buddhist constructs that would be useful to complement this perspective, but it does strike me that the action of psychedelics is, in many senses, trying to aspire to states of mindfulness, where if you're a skilled meditator, that basically means you now have some volitional control over the attention of the precision that you afford certain sensory sensations. Say it's my breathing, or another kind of modality, which of course is exactly switching off the precision of the deeper, higher internal structures, which would be in one sense a dissolution of selfhood, that is the read as having prior beliefs and constraints in the game when making sense of your sensations, that would be, if you like, the aspirational target of ultimate kinds of mindfulness. So I think there is a deep connection between the role of psychedelics in pharmacologically biasing your sense making to very precise low-level sensory inputs, and the same ambition of mindful states that are the holy grail of certain kinds of meditation. The final point I want to make in relation to or through the lens of psychiatry is that there are some very interesting out-of-body experiences and derealization, depersonalization experiences that people have that can be accessed through the use of psychedelics. And one of them is the sense that I am not me, or I am not even a person. This kind of depersonalization can be truly awful if you're subject to it. And what it tells you is that the hypothesis, I am me, is just another construct. And that it doesn't necessarily always have to be in play when you're making sense of your sensations. And we sort of take it for granted that it's me sensing and having these experiences, but that's just part of the self model. And it is just a model. It's just a hypothesis that we use to make sense of things. And there's no reason why you can't explore alternative hypotheses that I am not me. And sometimes if you commit to that, and that provides it is a better explanation for these very precise prediction errors that may be pharmacologically or pathologically precise, then you will experience a kind of nihilism of a deeply disturbing sort, where you no longer sense that you are you. And there are all sorts of interesting symptoms like Capgras symptoms, where that same kind of identification is transplanted to other people. So my wife no longer is actually my wife. She becomes an imposter. So a lot of things we take for granted in terms of selfhood and self-awareness can be very, very fragile in some psychiatric conditions or under some drugs. But I don't know whether that's the kind of Buddhist perspective that the questioner was chasing.
Just for your benefit, absolutely. In chapter 27 of the Diamond Sutra, it warns against nihilism, just for this exact point that you brought up so intuitively. So thank you.
Thank you. We're going to move on now. We have only 7 more minutes. We're going to move on to John and then Mehran. And then that was it. It's going to be end of it because we only got 7 more minutes.
Well, thanks, Ivy. I'll make this relatively brief. I'm thinking of telling my wife that she's an imposter so she doesn't whisk me off to the desert. At any rate, this has been great. I'm a novice physicist in all this. I'm only exploited by Ivy for my audio engineering skills, which I have so on display today. But I wanted to I have lots of questions, but I just one that's occurred to me over and over, and it's been something that's been nagging at me for some time, is this idea, people talk about the hard problem of consciousness, qualia and all of that. But it seems to me that the harder problem really is about curiosity, what you guys were talking about. Curiosity. I always use the word creativity. I try to imagine, for me, artificial intelligence will really be artificial intelligence if and only if it gets to the point where it can look out at the stars and say, wow, what is that? Maybe we could design a rocket ship and put things on it to go out there and take a look, or collect samples and bring them back. And that strikes me as a really hard barrier. Creativity, and it's lesser versions of that perhaps are in the arts and everything else, but anything having to do with creativity strikes me as the really hard problem of consciousness. And I wonder if you think artificial intelligence will actually get us to something. Will artificial intelligence be that good at any point? Is that even possible?
Chris, do you want to start?
Stump them.
I was going to suggest that you could start with that.
Oh, right. Yeah. Yes.
Yeah, it does strike me as a question, probably more for Karl, especially since that's what he's supposed to be doing, right?
No, absolutely. I think what you've just said is absolutely spot on. And I think that the next generation of artificial intelligence, is probably closer than you might think, and it does exactly rest upon this curiosity. So when Siri starts asking you questions as opposed to you asking it questions, then we'll know we're getting much, much closer. So I think you've identified exactly the next moment, the next GTP3, ChatGTP moment. It's going to be when these schemes are not just generating content for us, they actually want to know about us and how the world works, and they start asking questions that has this aspect of curiosity, this response to epistemic affordances that you are absolutely right, is one expression of creativity. And I'm just mindful of one of my friends, Jürgen Schmidhuber, the inventor of the long short-term memory, LSTM, that is in your mobile phones probably at the very moment. He's always played or told a story which produces a very close link between that complexity minimization, that evidence maximization, or free energy minimization that we were talking about before, which when read in terms of information theory is called compression. So the key role of compression in terms of getting simple but accurate accounts, as simple as possible, no simpler accounts of our sensorium. But that manifests in terms of behavior and actively going out there and doing smart data mining. It manifests as curiosity. It manifests literally, in his word, as artificial fun. So we come back to what Chris was saying before about play. Play is itself one expression of this uncertainty reducing imperative, whether it's children playing together or you playfully asking me ridiculous questions, or whether it is the kind of play, the kind of curiosity that sorry, yes, I've witted on for too long. But to my mind, fun, creativity, and curiosity are all expressions of exactly the next thing that we'd expect to see from our intelligent artifacts.
Very good.
Mehran?
Yeah, thank you very much to both of our guests as well as the panel members. I have a few questions, but I'm just going to narrow it down to one. And it is about one of the statements that was mentioned, to be an observer is to exist. I would have thought that in order to be an observer, at the very least, you have to exist, right? So because, for example, a book exists, right? But and because it exists, you can think about a Markov blanket around it. But again, having said that there is a Markov blanket around it, like if you want to say that it's observing because it exists, then you can think about, imagine a sensory state and an action state, but because it doesn't have selfhood, it can be, the sensory state would be to be read, to be thrown around, for example, in a completely passive sense. And the action state of a book that doesn't have selfhood could be palpating my eyeballs so that I could read it. It's not a state of aware sort of action selection mechanism. So just want to hear your thoughts, if there's time, both Professor Friston and Professor Fields, that would it make sense to say that in order to be observer, at the very least, you have to exist, and plus other conditions. Thank you.
Yeah, if I can start, I think that's very fair. I think the point that Karl was making with that slogan, and a point with which I agree, is that if something exists in the sense of it has a stable and weak interaction with its environment. So if we are outside observers, we can see that thing and say, oh, that's an object. That's a thing that's stable in time, that has persistence. If a thing is stable in time and it persists, then it is interacting with its environment. And that interaction is two-way. And it's the interaction, we may regard it just as thermal. Right? We may just see it as heat exchange, but it's still an interaction. And so this very minimal sense of observation that we've been discussing is just interaction. It's just physical interaction by systems that are systems that have a sufficiently stable boundary.
Yeah.
So go ahead.
No, after you.
No, I was just going to say that's what we mean by this slogan, that existence is interaction, interaction is observation.
And just to reinforce that point, and also celebrate the notion of a book. I've never been asked that before. That's an excellent example. Usually people ask about stones. I end up with Chris's observation that the stone is actually observing the temperature of the ambient environment. Thank you very much. And this is a very elemental, basal kind of observation, which is, that's not the kind of observation we're associating with curious creatures and with these deep structures, but it's still observation from the point of view from one point of view. But the book is even more interesting because it has a language in it. It is actually observing the human culture and the human race. So very much like desire paths in niche construction, things that basically exist and can be read as the environment learning about its inhabitants behind the environment's Markov blanket. You can actually read the printing of the book and the fact it was made by human beings, but also the content and the form of the book in and of itself as one way of observing its environment, but probably best read as learning about its existence. It owes its existence due to the printed word. So it is learning about you. Now, I know it's not observation in the moment, but at a certain time scale, it's a kind of observation.
Thank you very much.
It won't ask you any questions, so you don't have to worry about it being an observation.
So I think we wind down to the ending. We 4 minutes went out on both of your time. So can we all give a massive thank you to Professor Friston with us today and Dr. Phil today, please, everyone?
Yeah, it's nice. Thank you.
Yes.
Thank you, everyone.
And thanks to you all for interesting questions.
And Ivy, Happy New Year. 5 days late.
Thank you. Happy Lunar New Year.
Thank you for interesting answers.
Thank you. Yeah.
Thank you.
It's a quite an enlightening conversation. Thank you so much for both great minds. Thank you. Hope to see you guys soon.
Thank you very much.
Right. Ciao.
Ciao. And thank you, Ivy, for organizing this. A profound discussion, a really profound discussion in the question and answer session, which I think if anybody is interested should listen to the replay a few times, because they went very deep into the architecture of what consciousness is. Very profound. I don't think this is written, it's put in words. It's not put in words in books. This came out exactly through an exchange of conversations. And this is what these kind of discussions give us.
Just to be clear for people in the clubhouse room, we are still sitting here, and both Dr. Friston and Fields are listening in. So, you know, if you want to like sneak in some nice comments, that would be great too. But I think we are going to wind down the Zoom meeting because I have to go. Sorry, you guys. We're going to
we'll stop eavesdropping.
Right.
Well, thank you for as well.
Thank you very much, everybody.
I guess I'd like to ask.
Bye-bye.